Hello friends, welcome again to this session on use of 3D printing for exotic structure fabrication. Till now we have seen the use of 3D printing for numerous applications which involves mechanical manufacturing in the area of joining, in the area of orthopedic. Now this particular example that I am going to share in this case study, that will be on the use of 3D printing for development of a strategic tooth for canine. And in this case, we are interested in pre and post processing parameters optimization using the 3D printing, which is a FDM for the development of strategic tooth crowns in case of a canine. So what the idea is, you see in most of the canines, the strategy took, like you are seeing in this case, this is a canine tooth and this is the premolar. So if there is a damage because of some problem, the actual patient will not work for the intended duty for which that has been trained. Like for example, if you are having a smart dog which is trained for some narcotics department, or which is trained for some defense application, one of the first thing that they are being trained is, whenever they saw some antisocial element, they used to put a bite or impression over there. So similarly, on the other hand, if there is some antisocial element, so they also know that the dog is coming to bite them. So what they actually do, they have a titanium shell around their arm and all. So whenever the dog is approaching, they put their arm in front of it and they give a twist at a particular angle so that this strategic tooth is damaged, right? So normally in defense application, if the strategic tooth of this type of dog is damaged, it actually go back and there are chances that the antisocial element may overpower this type of the trained dog. So what the people do, they put a crown like this over this strategic tooth, who is going to actually perform some surgical task or operation over there. Now, the job for engineer over here is to prepare a 3D printed crown for these type of special cases. So, some literature review using a bibliometric analysis has been done. Now, what is the procedure? First is the selection of the subject. So, in this case, a 3-year German Shepherd dog was selected. So, I have to prepare a dye. So, anesthesia was given to the dog for the impression, then preparation of alginate, then dog biting through for making a negative over the cavity, then using the dental gypsum stone we get a dye stone model. Then based upon that dye stone model, in next step we prepare a CAD file, right? So we can go for the scanning of that data, also for the verification, modification of the surface as required by the scanning, virtual copying, then making a final CAD. Then for making a thermoplastic pattern, using a CAD model of the strategic tooth, we can operate on a printer setting, then removing the sport and getting the master. Now here we can do something like, once I have a master available with me, I can go for the investment casting and other way of the conventional casting, or I can just skip this step 3 and 4. I can directly go for the metal printing in this case. So in this case, since it is based on the polymer side, so the comparison of the master prepared by the thermoplastic based geometry and the die stone and the initial data has been done. Then the post processing was done for different heating cooling cycle, so that the effect of the temperature on the change in the dimension can be ascertained. Then measuring the different properties like hardness and other surface properties, followed by the multi-factor optimization. This has been tried in this particular study. So you can see on a dental tray, I am putting a alginate and taking the impression. You can see this is the impression taken for the canine. This is for the premolar. This is molar. Like we all know that PM4 and M2, they are the strategic tooth. And then making the Dyson model, putting a scan, getting a CAD file, and preparing this in the CAD format only. And then I can actually fire this on my system, right? So now here is some study, like people have reported the the optimization for the shell wall, like in this case it is fixed as 0.6, right? So we can plan accordingly, but as per the commercial industrial standard, this wall is kept normally around zero point 0.6 of the So some FE analysis can be done at this stage to understand that the this particular cavity wall is not going to collapse under the different type of the loading. And then by firing it on a system, and we can have the different orientation, like in this case it was printed at 30 degree, then 60, then 90. These type of the crown samples were actually prepared. Now this can be directly used for the investment casting application. So whatever the surface we got, we did some heat treatment. Basically, heat treatment involves putting the sample in a furnace at a particular temperature. Depending upon the grade we select, normally we put it below TG and try to see what is the change in the its surface through the scanning electron microscopy, getting the 3D rendering images and calculating the surface roughness values for these type of the samples. So for this purpose, we have used a open source software, which is a Guardian in this case, and try to develop a 3D rendered surface and of course the profile over here. So what we have seen in this case, by optimizing my process parameters for the polymer part itself, I can basically control the final finished surface of the cast dental crowns, specifically for the case of the dogs. Or alternatively, if we have a metal printer, the polymer printing part can be left and we can directly make a metal part through the metal printing, but that is not that cost effective. So one of the cost effective way that we have just seen, and we can assemble this finally for the use of my patient. I hope the information is useful. Keep watching. In my successive session, I will be discussing about the cases for the human as well as for the orthopedic application. Thank you very much.